John Merryhugh from Veloxiti Incorporated.
Good afternoon, everyone. I'm from Veloxiti. We're a small cognitive computing company in Alpharetta, Georgia. That's 20 miles north of Atlanta, Georgia, in a high-tech corridor. And we've been open for 27 years, and we build intelligent systems. So I'm just going to run through a few slides, tell you about ourselves. And I just pressed the button.
Play? Yes. Press the button.
Oh, that doesn't look good. That's not a button.
I apologize. Okay.
And then as soon as you press it, it should be able to go.
Okay. All right. Great. This technology has been around for nearly 25 years, funded by DARPA. Something like this is in the F-22 and the F-35 today. So Dr. Norm Geddes was our founder. He's still around, still with the company. And it's a way of thinking about solving a problem. There's lots of ways to do that, folks. We can use the 1-minute manager and make ABCs and say we're going to do all our A's today. We can do Weber's bureaucracy and have a lot of people staff it and think about it. We can just muddle through and just do the things we think are important. But this approach by John Boyd, the OODA loop, we actually took: observe, orient, decide, act. So when I was going through the Command and General Staff College in the early 90s, this was called Get Inside Your Enemy's OODA loop. John had a very interesting career. He was an acquisition person by trade, and they used to call him 30-second Boyd because he did fighter engagements and could beat anybody in 30 seconds. And they said, how could this be from an acquisition guy? But he was just that kind of mind. When he was a major in the 1960s, they moved him to the Pentagon. They said, help us build the next generation fighter. Why are we losing to these MiGs in Vietnam? And he was the one who said, you know what? One vertical fin's pretty good. Why don't you put 2 on an aircraft? A lot of pushback there, you can imagine. But he fought through it, and that's where the F-15 came and all of our advanced fighters. So what we do is we use that model. We've built a cognitive engine that reasons like that, and we put it in Army systems. So I mentioned the Air Force. They've used some of this. Something like this is being used by O&R and the Navy for autonomous software, autonomous submarine warfare, and we're doing work in aviation systems. In particular, we put this in the Cairo Warrior and did some teaming, man teaming with UAVs, 4 different UAVs, and ran tests with the Cairo Warrior pilot without the technology and the Cairo Warrior pilot who could command and control 4 UAVs. And it was basically an asymmetric environment. So it's an evolving situation. I mentioned the OODA loop and how it works, and it's all about making decisions really quickly. So this problem, making decisions quickly, isn't for every military problem. So most of what our soldiers do, they're perfectly good at. 95% of the time, the decisions you make are very, very good. It's only when you're in really complex environments and you have a lot of decisions and a lot of data that you make some decisions and you only realize a short period of time later, wow, that wasn't a good decision. I shouldn't have sent that UAV over there because now I've got a troops in contact, an IED attack, and I don't have anything to cover that. So our system tries to preclude some of that, and I'm going to show you a movie with this capability inside an application that we built for the Army. This cognitive engine we built, we've used several variations. The variation we're using right now is called the Velox Toolkit. It's built in Java, and it has a domain-specified language. So computer languages, there's one invented every single day in the world. And so we built this domain-specific language, so it had an adaptive API, and it can run in a command and post to the future environment. in a joint battle command platform environment, or in the application that we built for the Army. The interesting thing about having a domain-specific language running in an Eclipse tool is you could put knowledge into the system very, very quickly. So let me give you an example. The UH-60 Operator's Manual is 1,009 pages. It's a tremendous amount of procedures, rules, warnings, cautions, things that a pilot should know about. So we took this system and we read that book and we put it in a knowledge base and we spit out computer code that could be used to execute on board an aircraft. And we did that in less than 30 seconds. So that's the power of technology and software. And we're hoping, Colonel Bailey stepped away, but he had very good comments of what TRADOC is talking about. Yes, these are all problems. As a defense contractor, it would be wonderful if those things we have to fix were realized at a program manager's office, because the program managers have to deal with the reality of what the Army's budget is, the cuts that we're going through in our programs, and what can we do to leverage high technology to help our soldiers, because we're going to continue to get cut. We're getting eaten away. The Navy and Air Force, they made these hard decisions in the 2000s because they weren't really participating in the war that much, and they had to replace and automate a bunch of their combat systems. And the Army needs to do that, and now is a good time to do that. Okay, I mentioned the engine. So if you're not a software engineer, you wouldn't understand what these coding words mean. But basically, it's very adaptive, and any Java programmer can put knowledge into this system and support almost any domain. So I mentioned UAVs, I mentioned fighter aircraft, I mentioned helicopters. You're going to see something here for ISR and mission control. So this does a little build. This is kind of what the graphs look like. So this is, in technical terms, kind of a graph traversal system. There are two graphs that are linked together, and it looks and operates very much like the OOLOOP for John Boyd. And so most of this research was funded out of CERDAT, Command, Power, and Integration, along with ARL. And ARL, it was mainly the cognitive psychologists that are interested in how can your software think, and how can we measure that? So we did several experiments, and they used some metrics to measure this technology against a soldier without the technology. It was 42% better. And that's in reports. I can send that to you, and it's a little beyond me. I'll be very frank with you. So at this point, I'm going to show you a little movie. My colleagues are going to run that. And what this is, just a little Camtasia movie. It's a little marketing movie too, but I can kind of tell you what this is. So this is just an adaptive web interface. The government said, could you have this run on Android? I said, yeah, we can do that. Could you have it run on a cell phone for us? Sure. And so this is the Commander's Critical Awareness tool, and it only does one thing. For the S3, it answers every CCIR, Commander's Critical Information Requirements. Those are things you have to wake the commander up for, or you have to make decisions on. If you answer every one of those correctly, if you were an S3 at battalion or brigade or division over a year, you'd get a top block. You'd get an A. It doesn't happen. Probably once a day, there's some reason that the operations officer is speaking to the commander of, why don't I know about this? So some of you know what I'm talking about. So I think I got to play the. Okay. Gentlemen, go ahead and play the play button on the movie and just have it run. The other thing it does for the S2, so these things we call intelligent agents or associates run in specific domains. So the operations associate helps the operations officer. The S2 intelligence, it does one thing: answer PIR for me. Tell me what's going on. What are the priority intelligence requirements? And so it's doing that. So what data does it have? It reads all of the data on the publish and subscribe server. It reads all of the stickies and all of the tracks in Command Post of the Future. It reads all chat, all servers, all rooms. So if somebody's communicating about something, let's say right here in Huntsville, about a problem that I have, let's say in Kabul, Afghanistan, in my area of operation, and it influences me, and it's important enough, I'm going to find out about that. It's going to show reference. So here's our little user interface. In this case, you can see the little magenta dots along the road. We actually have an application we built for the Intel community that reads ground moving target indications. Very, very difficult to do, but we read those, and when something happens where these tracks aren't acting appropriately, some bad behavior, like an enemy TTP, we point it out to the operator. It says, this is very unusual that this vehicle stopped here, considering it's a curfew and they're not supposed to be stopped. Maybe their vehicle's broken down, but maybe their vehicle isn't broken down and they have a hole in the bottom of the vehicle and they're digging a hole there and they're putting a big piece of metal in there. So that in itself is not a big deal, but it picks up other things like after that vehicle leaves, you see a warm spot on the ground, usually through a UAV or a fighter aircraft. Sometimes a longbow helicopter will come along and say, hey, there's a hot spot there. Some activity has happened there. So this system takes those two pieces of information you would never be able to pull together at brigade or on a handheld at squad, joins them and say, you know what, there's a possibility there's an IED there, and warns our soldiers before it happens. So you can see here that the map zooms in and out. It puts the icon on the map for you. So where did I get that idea? Well, my last 3 years in the Army, I had to work with Command Post of the Future. Fantastic system, but had no intelligence in it. And just teaching a soldier at a basic training or a major at a Command and General Staff College could it'd take you hours to teach them how to put a track into the interface and put the right attributes on it. And I said, this is crazy. When I get out of here, I'm going to go to a company where I can kind of help people with this problem. Because there's always the same thing. How come I can't make this thing do what I want it to do? There's the information. Let the machine do what it's good at. Read other information that's in computer format, put tracks on my icon for me, tell me what's going on, so I, as a leader, squad leader, company commander, battalion commander, can make operational and strategic decisions. So the idea of using software as a strategic corporal are alive and well. So this technology is currently designated as Technical Ready Level 6. And we continue to promote it. We continue to use this technology in test evaluations. Our last evaluation was at the Army Warfighting Experiment in 2015 at Fort Benning. There, we built an associate for the S6. And it actually, during the whole exercise, replaced the Brigade 6 and provided information to the S3. So the S3, a contractor, did his whole job during the whole exercise, and he did the network management mission also, and he had the computer software enhance his ability, and he would just send out chat messages, okay, send a UAV over here, I need coverage here, my network is down here, and this was all done in WinT. Okay, so you can see there's a panel for current situation. So it takes the most recent thing and puts it on the top. So where does that come from? That comes from organization. Because when a commander walks up to a command and control system, they want to know in 30 seconds, what is the picture? What is going on? And I would look at people's pace boards and CPOF, and I'd see information all over the place, and you could not make sense of it. And every staff section was doing things differently. So this is just nothing but a standardization tool. You can see it's reading all the air tracks. We get those from TAEUS and Link 16, and we read as many of the attributes as we can. If it's Link 16, we'll read all 27 of them, and we put that into a giant, powerful statistical algorithm we call the ISR algorithm, and we use Jane's data, unclassified data, to make a recommendation with what asset you should be cross-queuing with. Additionally, not everything is kinetic. There's some non-kinetic things. So many times we give you an option, don't go kinetic here. Okay, these people they're having a riot in the field tonight. They're at this intersection, they're burning some tires. But you know what? This is Solder City. And it'll have it in there, make a recommendation for a shadow UAV to come down below its hard deck at 2,000 feet and fly over. What's happening there? Well, shadow's so noisy, it's scaring the natives, and they break away. And we've accomplished our mission without having to go kinetic, without having to have the risk of collateral damage. So that's a really important capability. So you can see there's a fusion of capabilities in here, different types of engines. So this is, I would say, a medium approach for the natural language processing. I don't think it's the best, highest approach, but it's an approach we use. It's well documented and gives us enough to understand what is happening in chat. We're not doing anything with voice. So the customers asked about that, and we should do things like that. I'm going to go back to my customers and, you know, we should do something in the voice area. It's getting important. I mean, that would be really good. Recommendations. So people ask me, I went to TRADOC 3 years ago, and the 3-star looked at this and says, is this thing running the war for me? Am I just sitting back? Have we gotten rid of all the majors and colonels? No, it's doing nothing but making recommendations. And it's doing that because it's read all of the documents, and it's taken the best business practices, the TTPs, from the best units in the Army and integrated them in a knowledge base. Now, you may say, well, the enemy, he's adaptive. He changes nightly. What happens if I want to change my TTP? We actually have a tab in here that you can go ahead and do that. So you have a new piece of information, or they're operating differently. Right on this user interface, you put the information in, and it goes right into the knowledge base and executes on the fly. So it doesn't do it for every decision, but it'll do it for most decisions, and it will seek out, what is this new thing? Mariu white bongo truck in this AO. And it will search out who's looking for that same thing, who has information on that, and then it will point out the combat activities to you. So uncertainty. So you could say, wow, you know, an Air Force guy, he's doing offensive and defensive counter-air, and the rules are pretty clean, and there's a lot of physics there, but how do you deal with that and the uncertainty of Iraq or Afghanistan last decade that some of us got to experience? Well, you can't. So what we've done is use some Bayesian reasoning to reason out some of these more difficult problems. Bayes was actually alive in 1647. And there are about 75 different ways to deal with uncertainty in the artificial intelligence field. We demonstrate only one of them here. And the place we demonstrate is with IEDs, and it has to do with machine learning, and the system learns, geez, there was a dead animal along the road and there was a hot spot, and then it sees an IED. And so the next time that happens, it says, no, that's no longer low risk. Apparently they're doing that in this neighborhood, soldier. This is a medium risk now. Again, it's not sending any type of orders. It's not doing a radio call. It's not sending a chat message. Soldiers, because we are human in the loop people. So we obviously have people who served in the Army that know we just can't automate everything. That's impossible. I mentioned autonomous systems and robots. So this approach has been tried and tested with robots and humans in the loop. A lot more work needs to be done there. We're very interested in that field, and we think that the Army is going to be interested soon in that field, considering the dramatic downturn of our funding situation. So what else is happening here? So we're typing something into the chat message where this is a new vehicle, a new activity, and we're sending it in, and it pops in. You see the map zoom. It sees C2 is sent to the user. So we just got rid of that 5 to 7 minutes. Remember the major who couldn't get the icon onto the map and pull it into the repository so everybody else could see it? No, we just took care of that in a second and a half. So that's what I'm talking about when we talk about agile thinking. Now he could start thinking, what do I do about it now? The last thing you want to do is, if you have an evildoer out there, is let them run around for 45 or 60 days and, geez, we'll let somebody in the United States figure out the problem. No. Solve the problem tonight. Okay? And if you can, try to take down the network tonight. Don't wait around and let some evildoer continue to harm and maim our soldiers. So that's the whole logic of why we built the system. We can continue to build systems like this for the Army. Again, you could see in the ISR assets there are different sensors. So in this case, it understands I have an Apache, I have an A-10 aircraft, and I have a Hunter. It's actually advising, as far as sensors, Hunter is the best. But because the Apache's so close, he's probably the best guy to call. And in the experiments we did, we actually gave a call sign for the operations officer to make a call to someone to call that Apache in. So this technology can also be used as a training capability for the Army. So I'm just going to let that run, and I'm going to end there and see if anybody has any questions about software that thinks, intelligent agents.
John, traditionally, I ask the first question.
Yes, sir.
I think, if I understand correctly, the inputs right now at TRL 6 are done by programmers versus subject matter experts, correct?
All of the knowledge in this system was done by me. I had 4 tours in Iraq, and I used all the doctrinal information for each of these roles, from technical manuals, field manuals, and then I went to the best units I was aware of. So for aviation, that was the 1st Cav Division, and I took their TTPs and integrated it into the knowledge.
It's just human language interface with machine language, or did you have was the programmer in the middle to convert?
The program was in the middle, and he fat-fingered it in.
So in the TRL 9, is it just straight human language to?
We think it's going to be something like that. It was only last year that DARPA funded us and said, take all these documents and get rid of the software engineer. I want you to read everything and dump it all into computer software and just spit out code to tell the system what to do. In this case, it was an autonomous aircraft or autonomous helicopter. And we demonstrated that capability. So more work needs to be done there, but that's where I think TRL 9 looks like.
So it's still more in the DARPA?
Yeah, that type of thing where it's a dark science doing knowledge engineering. And what we've tried to do is take the knowledge engineer and take the engineer out, give the application government purpose rights to the government and say, go ahead, you can use this as a capability.
Could you tell us a little more about the manned, unmanned demonstration that you talked about earlier?
Yes, sir. That was done last year at the Air Maneuver Battle Lab at Fort Rucker, Alabama. We had 3 one-week experiments. We brought in best in breed, so at that time it was a 517 Cav squadron. They're instructor pilots. They mixed them in. We had CW2s all the way up to CW5s, and we ran 4 different scenarios. One in the city that emulated a place like Tikrit, one in the mountains north of Tikrit, one in Sadr City, and one along the road at Tampa. These are places you might be familiar with. And we ran these experiments, and one crew had a common ground station and a human operator, and that crew would communicate with the CGS and cross-queue with its UAV, as it's done today. The other crew had this software integrated in a 3rd tactile display in the cockpit. Everything was automated, and he pushed buttons doing tactical cross-queuing. And we measured the result. And it was about 56% decisions faster and better with the crew that had the automation. The human, it's just hard for them to keep up. The radio communications, say again, over, even in simulator, it's a little noisy and it's hard to understand what's going on. So all of that work was done, and we transitioned that into a DARPA project called Alias, in which we did what I talked about, is reading documents, making sense of them, putting them in a knowledge base, and then transitioning that into a domain-specific language that could be integrated into a language that the aircraft would understand, in this case C++. Any other questions? I'll be here for the next 2 days. We have a booth right down yonder here, right in this hall.